Let's begin with a quick look at the announcements. Remember that your first homework assignment is due by 1 o'clock on Monday. And that has to be a PDF file that you upload. It can't be JPEG files because those don't display quickly and you can't flip between them in the same way that you can with the PDF. So if it's a JPEG or some other file format, it won't be scored. Make sure that your assignment's in focus, that it's grayscale, meaning that it's not color, it's black, white, and gray. And then don't use lined notebook paper. Either use the engineering computation paper that I gave you or just plain unlined copy paper. Does anybody have questions about homework number 1 and the expectations for submitting that? Okay, we're going to continue talking about some concepts from chapter 1 in the book today, and specifically we're going to introduce the idea of cash flow diagrams, which is a way to quickly visualize time value of money problems. So there's some terminology that we need to briefly discuss and define. By inflows, what we mean is money that a company or individual is receiving, like revenue. Sometimes that's called receipts or income. But cash inflows can also include something that's a little bit counterintuitive at first. It's here in italics. Savings generated by projects and activities that flow in. So let's say, for example, that you owned a shop, a machine shop, and every month you had to pay $500 to heat it. Maybe you're buying propane in your machine shop and it costs $500 a month. If you put insulation in and then suddenly your heating expenses went to $100 per month, then that $400 savings counts as an inflow. Because presumably what you would have done is spent some money in a lump sum right now, and then you're going to realize savings in the future. So inflows can include revenue that you're receiving from clients. Inflows could be a loan that you're receiving that you're going to have to pay back someday. But it can also be expenses you used to have that are now reduced because of some action that you took. So does that make sense to everybody? So inflows, we give a plus sign. It's money that we're getting. Outflows, on the other hand, sometimes are called disbursements. They can represent costs that we incur for doing projects. It can be expenses for things that we own and need to operate. And then outflows can also include taxes on the revenue that you receive. So if you get $100 in revenue, but you have a corporate tax of 25%, if that $100 represented profit, then you'd have to pay $25 in taxes, and that would be a separate outflow. So it's just another instance of an expense. So outflows will assign the minus sign. Now the net cash flow is the difference between the inflows and the outflows. And so during a monthly period, maybe you have some of both. Maybe you have money coming in from your clients and the projects that you're completing. Maybe you've got money going out due to payroll that you're doing or insurance, equipment calibration, and so on. The net cash flow would be the difference between the two, where you have the inflows minus the outflows. Now, the outflows should be an absolute value of the outflows. It shouldn't be a negative value that then you subtract and then that would like add to your net cash flow. The main idea is that the net cash flow you should think of as the difference between your inflows and outflows. So in other words, it's your profit. Net cash flow is sometimes referred to as the profit. Okay, now here's a really important assumption that will always apply unless otherwise mentioned. If we operate on kind of a monthly basis where we're paying all of our bills once per month, we get receipts and tally them up on a monthly basis, our payroll is done on a monthly basis, depending on what the period length is, maybe the period is a 2-week period or a monthly period or a quarterly period. Regardless, we're going to apply an end of period assumption which says let's just aggregate all of the inflows and outflows that occur over time, and represent them as a lump sum at the end of the period. So let's say you're an Uber driver, and you're making money every hour. Every ride you're making money. But just for simplification, what you ought to do, according to the end of period assumption, is just gather all of that together and make it a lump sum of revenue at the end of the payment period. So if Uber actually pays you out once per month, then you do that. And if your credit card is due once per month, and that's how you pay your fuel bill and all the other expenses, those are all taken together, and at the end of the period is when you'd account for the inflows and the outflows. And I'll show you on cash flow diagrams how we do that end of period assumption. So cash flow diagrams are a quick and easy way for us to translate what otherwise would maybe be like cumbersome language, like word problems, and turn it into a figure that's really easy to understand. So why would we want to graphically represent money flows? Is just because it's a simplified expression. It's faster than natural English language, and you don't have to know even English to understand a cash flow diagram. And also it helps to remove ambiguity. If you're explaining to another person what you mean, sometimes in words or in language there can be confusion that would be avoided if you show it as a diagram. So here's an example of some English language that's talking about a time value of money type problem. You borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? So in that, it's implied that when you borrow the money, you're getting it now. But it didn't explicitly say you're getting the money now. And that's the most reasonable interpretation, because if it was at any other time you were getting the money, they would have said that. But it's not explicit. The other thing that's not explicit is it says you're borrowing $10,000. It's implied that you're getting it all at once, that you're not drawing it in multiple intervals. But that ambiguity can be eliminated, and you can express what you mean with a cash flow diagram that is a lot more explicit. So here's how we do cash flow diagrams. We draw a horizontal line. 0 represents now, the present. And then each one of these tick marks represents a period. It may be years, it may be months, it could be weeks. Whatever our compounding period is, that's what we use as one of these tick marks on the line. Money that's above the line represents inflow, so that's money that we're receiving. And if it's outflow, it's money that you're losing or paying, then that's going below the line. So here's how we translate this statement or this problem into a cash flow diagram. You borrow $10,000 at 6% to be paid back after 5 years. How much must be repaid? So this is a question like, we don't know the answer that must be repaid in 5 years. So it would look like this. There's a solid line up, this arrow in the amount of $10,000, and you can see it's at time 0 at the present, so P means present. And then somewhere adjacent to the cash flow diagram, you define the interest rate per period. Here it's 6%. And each one of these tick marks represents a year. So you can see that we've got an arrow at year 5 that's a dashed line. The dashed line means we don't know the amount. And then the other way that you indicate that the amount is unknown, just with these question marks here. So F, the future amount, is unknown. So inflow above, outflow below. So you get $10,000 now, and then you have to pay a lump sum in year 5, but we don't know the amount. This cash flow diagram is from your perspective. Remember that on Wednesday we talked about the difference in perspectives. So what would this cash flow diagram look like if it was from the lender's perspective instead of from your perspective? It would be the reverse of it. It would be the mirror image. So from the lender's perspective, they pay $10,000 at time 0, and then they receive some amount at year 5. So pay special attention to the perspective that's mentioned in the statement before you translate it to a cash flow diagram. Probably on the exam, I'm going to give you a problem, and then I'll ask you to diagram it from the perspective of the lender. So you'll have to be very careful to the details in order to get it correct. Okay, so the symbology that you've already seen, P means a present value amount, F means some amount in the future, N is the number of periods that's described, and then I is the interest rate. And sometimes we'll express the interest rate as a decimal, so I would be 0.06. Like if we were going to be putting it into a spreadsheet, we'd want to write 0.06 into the spreadsheet file. But then if you're just doing hand calculations, then it's okay for you to write I equals 6%. Or you could write I equals 0.06. Either one of those could potentially be fine. So, seems like the computer's a little bit locked up. Not responding. I don't like that. Well, while it's thinking or not, I'm going to hand out the in-class exercises, at least so we can get that out of the way. Okay, it's back. I wonder if the recording's still going. Looks like it. All right. So don't start on the in-class exercise yet. There's a few more things I want to tell you before we get started on that. Okay, so here is how you would translate this statement into the appropriate variable labeling. P equals 10,000, I equals 6%, N equals 5 years, F equals unknown. Now, for cash flow diagrams, sometimes we know the exact amount, and other times we only know a range of possible values. Most of the time this semester, I'm going to tell you, for example, that you're going to receive $150,000 a year, for example, for a certain project that you're about to do. But the truth is, in the real world, we don't know everything about the future, especially if you're introducing a new product to market, or if you're trying to get a contract, or if you're trying to predict how expensive things will be in the future. There's a lot of unknowns about the future. So in other cases, if we don't exactly know what the amounts are, we might express a cash flow diagram in terms of a range of probable amounts. And so, for instance, if we knew that probably we were going to receive between $135,000 and $150,000 per year, then this lower figure would be a way of representing that. Instead of a point estimate, which is just a single amount we pretend to know about the future, this is just acknowledging that maybe it'll be somewhere in between 135 and 150,000. So I just wanted to make you aware that uncertainty exists in the world, and here's how we would diagram that with a cash flow diagram. So when you're given a cash flow diagram and need to interpret it, there are some important details of what you need to be aware of, or if you're sketching one, some things that you ought to include. So where possible, you should annotate present value, any amounts in the future, or here A is an annual series, and it's only an annual series if the amounts are the same in successive years. So like if there's a gap, if there was no arrow in year 6, then it wouldn't be a continuous annual series the whole way from 3 till 9. It would be an annual series from 3 to 5, then a separate annual series from 7 till 9. So be on the lookout for gaps that break up an annual series, or if it's different amounts, then it wouldn't be an annual series as well. The arrow size doesn't have to be scaled exactly, like down to the millimeter in terms of the amounts, but it is a good practice if bigger amounts have larger arrows than smaller amounts. You know, if directionally you can get a sense for whether something is a lot or a little from the size of the arrows, then that's good. But I don't expect every one of your cash flow diagrams to be perfectly scaled. The interest rate, it can be below the line or above the line, just depending on where is a convenient place to write it, where it's not going to get in the way of the arrows. And then if there's an amount that's not known, it's best to represent that unknown quantity with a dashed line and then a question mark after the label. Now here's something that inevitably on the exam people make mistakes because they think that the number of years shown on the cash flow diagram is automatically n. So it's not. Like year 10, 11, 12, 13, the years after the amounts where things are actually happening, they don't matter. That cash flow diagram is empty after year 9. So pretend like it's not even there. You don't necessarily have to, if you're translating the cash flow diagram into a spreadsheet, there would be no need to have a year 10 row, a year 11 row, a year 12 row. Same thing is true on this lower cash flow diagram. The last thing that actually happened was in year 10. So 11 and 12 are empty, so they can just be omitted from any table that you prepare for that. Okay, so now we're going to get started on this in-class exercise. I'll bring it up on the screen just so that it's included in the lecture video. Remember, you're totally good to talk about this with your classmates, compare answers, make sure that you're in the same mindset there. But when you've got the drawings done, if you want to see if you've got it correct, I have the solution, so I'll be circulating around as well. So just let me know if you want to have a look at mine. You want to check the solution to problem 1. It's up on the screen right now. So for problem 1, you get 10,000 now at the present, and then you make 4 annual payments. If you're paying that, that's an outflow to you. There's 4 of them. They're all $3,300, and that's an annual series, so we label that as A. The arrows should be approximately the same length for years 1 through 4. Okay, so let's pause for a moment just to get some details about problem 5. Okay, what this formula says is that if you know a certain amount in the present, you can find the future equivalent of it by taking into account the interest rate I, and I is going to be expressed as a decimal there, and then n is the number of periods of compounding. So in this problem, what it's saying is if you got $10,000 now and $5,000 in 1 year, how much would you have to pay back in year 5 if the interest rate is 6%. So the future is unknown. You know the present. Now, this $5,000 in year 1, that's not in the present, so to speak, but you can pretend like that's the present if you change n. So like, I'm saying you should solve it in parts. Find out what is the future amount you'd have to pay back for the $10,000 if n equals 5. 1, 2, 3, 4, 5. And then the $5,000, just pretend like that is a loan you received that has a duration of 4 years. So let n equals 4 for that for the $5,000 that you're trying to find out the future equivalent of it. So the total length of this arrow at year 5 is going to have 2 pieces. It's going to have the amount you have to repay because of the $10,000 that you got that had 5 years of compounding. And then you're also going to have to pay back a certain amount in year 5 because of the $5,000 you received at year 1. And the amount that you received at year 1, it doesn't compound for 5 years. It only compounds for 4 years. So n equals 4 when you're using this formula to find the $5,000 future equivalent. Mm-hmm. The answer to number 3 is up on the screen.
So we don't need to worry about interest in number 3.
Right. Yep. Problem 4 is an example of the kind of trick question you might see on an exam where I tell you some scenario and then at the very end I say, do it from the other guy's perspective, not from yours. Do you have a question?
Yeah, I was just, you have years 4 and 5 on there. Is that essential for like total accuracy or is that?
No.
Okay.
Nope. It's just, it means nothing. The last year that something happened was year 3, so it doesn't have to be, 4 and 5 don't need to be there. All right, so this last one though. So sometimes I think it's useful just to like get your pencil and count the number of years into the future you're moving an arrow. So I think of this 5,000 amount, it's part of what contributes to the length of this arrow at year 5. So we're moving this money into the future. We're compounding it into the future. I'm going to use that as a verb. Compounding into the future. It means making the amount larger because of the effective interest. So if I'm compounding it into the future, it's compounding 1, 2, 3, 4 years. And so the length of this arrow is $5,000 compounded 4 years into the future at 6%, and then $10,000 compounded 1, 2, 3, 4, 5 years into the future at 6%. So n equals 5 for the $10,000 amount, n equals 4 for the $5,000 amount.
But this is a simple interest, not a compound interest.
No, it's compound interest. This formula takes compounding into effect. It's built into the formula.
All right.
Yep. Good question. So let me show you the solution for this last one. So what we do is we've got the 10,000 that's moving 5 years into the future to get to year 5. So $10,000 compounded 5 years into the future is worth $13,382 and 20 cents. 26 cents. And then this is an error there. The F2 is 5,000. I think the amount is correct, 6312.
Yeah.
But I need to change that to say that's actually $5,000. Okay. $5,000 times 1.06 to the power of 6 is equal to 63.12 and 38 cents. So then we add the two together, and then the lump sum amount that we'd have to pay in year 5 is $19,694. That's the economically equivalent amount. You're going to hear that phrase economic equivalence a lot this semester. And so sometimes what we'll be doing is we'll be moving money into the future, which is compounding. Other times we're going to be moving future amounts back to the present. So for example, if somebody tells you that they'll pay you $8,000 8 years in the future and it's 5% interest rate that you're experiencing, you'd want to know what's the present value of that future amount. We call that discounting, when money is moving backwards in time rather than forwards in time. So we'll get that in due course. Does anybody have additional questions on today's in-class exercise? I saw some of you have already finished the homework assignment. That's great. I'm glad that you're getting an early start, working ahead. I do have office hours this afternoon from 2 till 4, so I'd be glad to help you if you have some specific questions on the assignment. I do occasionally check my email over the weekend, but I also have a life. So if you've got questions, I'll do my best to respond, but it is a lot easier sometimes just to do it face to face. And so stop by and see me if you can. Otherwise, I will see you in class on Monday.